YouTube, what's up? What's up? What's up? What's up? What's up? How's everybody out there doing? So we're on part 2 of the grade 3 hardest math problems. I have a link here, GregsTutoringNYC.com/hardest-math. Okay, that's our link to where this series of videos are here. Again, we're in part 2 of grade 3. We're also in part 2 of the whole series, because I did a whole bunch of this series, which you can find at that link, dealing with multiple choice questions. These are show your work questions. They offer a different dynamics and a different perspective into the different math being offered. Again, I sourced these from the New York State exams that are given to hundreds of thousands of kids. And basically, if students are getting more than half of it wrong, these are usually the problems I'm showing. In the show your work examples, that was probably true for every question. So what I'm just going to do is go through some of the exams that way. That said, this is not about exams. This is not about gaming systems. This isn't about taking standardized tests. This is basically about finding why were these problems the hardest, and let's try to point out concepts and topics. Okay, so with that in mind, let's jump right in here. Let me get rid of this cover screen. And this is our first problem. So let me make sure our tab is right. So again, on a lot of these are grade 3. As you can see, they're dealing with a number line. And it's about basically groups / equal parts / the concept of a whole, right? That's where the 0 and 1 endpoints come in here. And even at that, we're dealing with endpoints. Let me get my tablet working here. Okay, there we go. So we have 0, 1 endpoints. We have 1 as the concept of a whole. Okay, and this 1 can work 2 ways. It can be conceptually a whole, or the example might talk about, say, a mile. Okay, and now therefore we're going to have that come into play from that perspective. So we're going to look at the illustration first. That's my modus operandi in a lot of these. And all we have is a number line with the 2 endpoints. There is a midpoint in here, or what appears to be a midpoint. So remember, when you're looking at illustrations, you're only making educated guesses, and finally you have to go back to the words to make sense of it. So that tick mark there looks like what I labeled M, looks like it's the midpoint. I'm not sure though, but that's what we got to go by. We don't know if it's part of the problem, or it's just there to distract us, or it's just there to help us, because if that's the midpoint and we need to do other tick marks, we can kind of use that as the guide, okay? So if there was a quarter, right, if that was a half, if that truly was a half, then if I do half of that, then this must be a quarter, all right? So before going too far gone in the number line, because we don't know what the question is, and there's nothing else being offered there, let's go and look at the words finally. So Haley cut pieces of ribbon to make a bookmark. Stop. I read each sentence and try to break it down by phrases. There's no other phrases here. She's making bookmarks out of ribbon. Each bookmark was 1/8 of a foot long. Okay? Draw a point at 1/8 on the number line below and label the point A. Okay? So I kind of went halfway there already without knowing what the question was. Because if I do another tick mark here, okay, I'm half of a quarter, so I'm at 1/8. So this would be A. Okay? And that's pretty much the question. Now let me change the color slightly for a minute. Because working with students, I see various things happening. If the student said A was here in the blue, that can't be true because it's too tiny. And if the student, even though they noticed, the student may have observed this was the half mark, if they said A was over here, that's way too far over, so it can't be that either. So it's not good enough for the student to know that it's either here or over here. It has to be more accurate. Now, the students are being asked to do this without a ruler, right? And things like that. But we can see that this X here and this X here, they are not 1/8. We can tell that. Now, let me change the color one more time. Let me make it purple. if the student drew A right there, okay, and said that was A, this one's a little more suspect, and it would probably be graded correctly, especially because the student doesn't have it, okay? So without a ruler and so on, this by I is probably, the purple line is probably reasonable answer for that, okay? So there's issues like that. So let's reread it to make sure we got where they're going. Haley cut pieces of ribbon to make bookmarks. Each bookmark is 1/8 foot long. So its units are in feet here. Draw a point at 1/8 on the number line below to show it. So if we want, we can add on to here that this is really 1 foot and this was 0 feet. Because that's what this is about. The concept of 1, and this time they're talking about feet. Okay? So this 1/8 here would actually be 1/8 of a foot. Okay? And it doesn't matter that they didn't put FT right there in the question. Okay? Because it's the concept of 1. We're taking equal groups in this case. You'll be dividing this 0 to 1 into 8 pieces. Okay? And on that note, if we really wanted to, that could be what a student may have done. So let's make it black. So we could do half of this, half of that half, half of this half. We're going from the quarter to a half now, so this is that. Okay, we could extend this down, right? We can extend that down. We can extend that down. Extend that down. So we can see that we have 0/8, 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. Okay, so we can do that for all those. And again, it's judging by eye. If you notice, my gap right here is larger than say the next one right here. They're not looking for you to get this totally exact, but it has to have some level of semi-accuracy to it. Okay, so we beat that around a lot. So Haley placed. Let me erase this so you guys can see some of this. In fact, let me erase this whole thing at this point so that you could be clear on what the answer was, so that we can do the next part. Get rid of all this clutter stuff here. What was that? That was there. All right, so we should be able to pop in. So let's go back and re-answer the original question. So if this is a half, then it seems to me that about right here is a quarter. And then it seems to me that half of that half is about 1/8. So that would have been point A. Okay? So the next says, Haley placed 5 of the bookmarks, end to end. So that means Haley put a bookmark, and immediately right after it, she put another bookmark without a space. And immediately right after that, she put another one without a space. And then she did that 2 more times to get 5 of them in a row. Okay? So it says, draw a point on the number line below to represent the total length of the 5 bookmarks. Okay? Well, if each bookmark, it says right here, each was 1/8. Then we're talking about looking at 5/8. So if this was a half, and this is a half of a half, right? So we're looking at 3/4 then, which is 6/8, and a half is 4/8. Then 5/8 must be right here, or about right there. Okay, and it says label that point B, so that would be B. So right, if we lay out the 5 bookmarks, and it's really at each of those points, right? So the first one would go to there, the second one would go to there, the third one would go to there, the fourth one would go to there, and finally the 5th one would end there, okay? Because we're starting from 0. Even though that was supposed to be a tick mark, but we're starting from 0, okay? So we have 1/8, 2/8, 3/8. We already said the half was 4/8, and then finally the 5/8. Okay? And that's all they're asking for you to do there. That's all they're asking for you to do right there. Just give me 1 second to make sure this is actually retaining the stream. Okay, I noticed the question got cut off, so I'm going to drag this down slightly, even though I said the question a few times. And if you got confused with that, you can go back and replay instead of me restarting 15 minutes of material or whatever. All right, sorry about that. It's showing on my screen and it's being cut off for some reason, so I'm not sure why that's occurring. I'll have to figure that out for the next stream, because I noticed it did that on the first stream as well, and I meant to get that resolved this time through. Okay, so again, it's not dealing with 100% accuracy, but it wants you to basically get the right ballpark position, and it's going to be about from here to here is about the right place where you could have labeled D. If you put D over here, that's no good. If you put D before the half, like let's say over here, anywhere over here, that's absolutely no good, okay? This is estimating, but it's not guesswork, it's not random, it's not arbitrary, okay? Now, given that's the answer, what I'm going to do is I'm going to erase the whole second answer, because kids get a little confused in the question and they answer a different way. They answer a different question even. What they try to do is they split the number line here up into fifths, because this says there's 5 and they see 0 to 1, and they think it's similar to the way we solved the first part of the problem. So if we do that, and this is kind of guessing because you have to split into fifths. Let's see, a quarter's there, so that's about 1/5. This is about 2/5. This is about 3/5. And this is about 4/5. Okay, so what some of the students do is they say, well, 1 is, some of the ones who know it, 5/5, the number over itself is 1, except for 1 is 0. They say that point B is over here. Okay, that's wrong, because it's not saying to split the number line into 5 equal parts. It told us up here that each bookmark was an eighth. Each bookmark was an eighth. So we're dealing with 5/8 of a foot. Okay? We're not dealing with 5/8 of a number line. Or in this case, 5/5 of a number line. That's not what we're doing. So be careful with a question like this. A lot of kids, I would guess, lost a lot of points trying to solve the problem in this manner. So yes, the concept behind here is 1 as a whole, but we have to look at what units we're dealing with, right? It said each was 1/8. So we have to stick with that, all right? So that's that question. Okay, so we have an analogous situation here with an illustration. We have what appears to be a 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6, 7. We seem to have a 4 by 7. Okay, so depending on how we approach that, it depends on what the question is as well. Okay, and what I like to do is I like to either number the numbers like I did here, or if I'm counting, I have to use my pencil 1, 2, 3, 4, right? I have to start from 1, not from 0. And the other way is going to be something 1, whoops, 2, 3, 4, 5, 6, 7. Do it that slow, because when you do it fast, you can be off by 1. I also like to go backwards and count it backwards. 1, 2, 3, 4, 5, 6, 7. It checks out. So I definitely have a 4 by 7. You can also look at this as a 7 by 4. Okay. I don't know what the question is, so I'm just going to leave it at that. There's stars there. There's shapes. right? They each have 1, 2, 3, 4, 5 points. There could be a whole bunch of questions they could ask us here, okay? And we noticed it's labeled, it says page 1. Let me erase that there. Okay, so it says page 1 there. So we don't know what else to grok out of this. So Katie received a sticker each time she picked up her toys. Let me make sure that's coming on the screen. Give me 1 second. Nope, it barely is. Okay, I'm not sure why that's happening. Let me make sure it's showing for you guys. Wait, we can get as much on the screen as possible. Okay, that seems to be showing. Katie received a sticker each time she picked up her toys. Stop. So it seems to be that she's recording the number. A sticker may have been a star. She was recording it. She placed some of the stickers on page 1 of her scrapbook. So she placed some of them. So it seems like she and this would be 28, right? She put 7 times 4. This is also 28. So she put 28 stickers on the first page, right, of her scrapbook. Write numbers in the blanks below to show 2 multiplication facts represented by the array of stickers on page 1 of her scrapbook. So it seems to me that's the 2 numbers that they want. The 4 times 7 is 28. And the 7 times 4 is 28. Okay? That seems to be the most straightforward answer. There seems to be sidebar answers to this, and I'll get to that in a second. So it says Katie placed the rest of the stickers on page 2 and page 3 of her scrapbook, as shown below. So let's bring that up. So it seems to me if we have similar stuff, we have 4 going this way, 1, 2, 3, 4, and 4 going this way, 1, 2, 3, 4. We can also put this on here, even though we've just put it on the left side, 1, 2, 3, 4 by 1, 2, 3. Okay, so they're probably going to ask us something similar to what they did above. Let's see. Complete the expression below to represent the total number of stickers are on page 2 and 3. So this seems to be where a lot of kids kind of get their minds blown. So if we look at what page 2 is, it's a 4 by 4. And unlike the example here, if we rewrote that to put, if this was A times B, right, up here we had basically A times B, and then we flipped it to B times A. Okay, if we do that here, we still get 4 by 4. So there's really only one way to approach this. Now page 3 is a 4 by 3, or it's a 3 by 4. All right? So what they're asking us to do is to fill this in, right? So if we notice, if it's 4 times 3, and this is, 4, and this one was 4 times 3, okay? So that would give us the 4 here, a 4 here, and a 3 here, okay? And we can kind of prove it, because if we would have merged these 2 pages together, we would end up with 1, 2, 3, 4, and if we keep going across, 5, 6, 7. But that's what that's equal to over here. This is 4 times, and 4 plus 3 is 7, right? And this turns out to really be the same example over here, except she split it across 2 pages. All right? So, as I discussed in the previous example, this is the distributive property. A times B plus C is equal to AB plus AC. And there's other aspects of the distributive property. And we can also go backwards. If we have AB plus AC, we can also simplify that backwards to A times B plus C. So that's what we did here with the 4 times 3, along with the 4 times 4, right? Because basically what we have is 4 times 4 plus 4 times 3. That's going to give us the total number of things, which we know was 28. So here it's 16 plus 12, we get 28. So if we have 4 times 4 plus 4 times 3, we can reduce that to 4 times 4 plus 3. Okay, and that turns out to be exactly what the question is asking us to do. All right, so this is grade level. This is moving away from parts of a group, but it's also about thinking of how to take a whole and split it into sub-pieces and break it up into other stuff. And it got into terminology with the distributive property. Distributive property. All right. Now, this example also is conceptual in the sense that it's not only talking about grouping, but it's dealing with your multiplication table. Right? If you don't know the multiplication table, you can get it wrong. So if you didn't know if the original answer up here, 7 times 4, enough kids might write 29. That's no good. Or they might even write 35, think it's 7 times 5 or something like that. Or 4 times 6, they might get 24. That's not a good answer either. So there's a couple of reasons and dimensions of why you could be ending up getting this incorrect. All right? Now, I mentioned earlier when I was writing this here that there's a little twist to the example, and it's more clearer when we look at this, because it turns out there's other ways to answer this question. Okay, there's alternate answers which will give you full credit. Okay, one might be that because we know there's 28 in total, we could have said 1 times, and then get this as 16 plus, and the other one was 12. That is a valid answer. Okay? We could have also said 7 times 2 plus 2. Okay? Because that's 7 times 4 is 28 as well. We could have also said 4 times 6 plus 1. Now, even though these are technically correct, they don't really model page 2 and 3. Certainly this doesn't really. This comes a little closer, depending on how we look at it, because we have the 7 times the 2 times the 2. And this one, so really it's only this one that would be more conceptual, that you're putting the 2 page and 1 together and just saying they're a unit together, right? That's kind of okay to say, all right? But those are really pushing at answers, okay? So with that in mind, we can come back up here and theoretically say this was 2 times 14, okay? That still gives us 28. And I'm going to kind of parenthesize it and put a cross through it because it's not really what they're trying us that we should be shooting for here. We're trying to model what's being presented to us, and 2 times 14 is not really helping us unless we were to group it in a different way. Let me change the color of the pen here. You know, if I was to draw a circle around this and also a circle around that part so that we have a top part with 14 and a bottom part with 14, then this kind of answer would make sense. But that's not the grouping they're presenting to us. So even though they both produce 28, and the same with the things down here that I did, that's really pushing what the answer should be. All right, but it's just to show you there's alternate ways of solving problems. Sometimes you can solve a problem with an offside way to do it just to try to confirm it, although I agree this is pushing it in this case. Okay, and by the way, in these kind of solutions here, we're really looking at factors, which again deals with your multiplication table. Okay, so the concept behind these alternate solutions would be factors and multiplication table. I'll put MT there. All right, so that we're getting some sense of where we're going here with some of this. But really, the straight up ones is look at the table. It's a 4 by 7. Look at page 2 and 3. It was a 4 by 4 and a 4 by 3. And then see where the distributive property kicks in here. That was the concept they really wanted to get out of this, that we can do those things. And by the way, the distributive property is built on another concept which you're going to probably learn around the end of 7th grade or so on. All right, so that's that. All right, so 47 is there. Let me make sure we're not scrolling off the screen again. Nope, we're not. Okay, so we're going to look at the illustration. We have favorite sport activities. Basketball, volleyball, so you have different activity sports. Number of students is not there, and we have to note this right here. Okay, so it says the key, this means it's 2 students. So whenever it's not 1, we need to kind of be super observant of what's going on in this. Okay, we don't know what's going in the table yet, so hopefully the words are going to do that for us. But it just seems to be, it's just recording the number of students per sport, okay, in terms of the favorite activity. So let's go look at the words. Several students voted on their favorite sports activity. 8 for basketball, 3 volleyball, 7 baseball, 4 kickball. Complete the picture graph, that's what this is called, below to show the data. So we know there's 8 here, okay? There's 3 here. We want to make sure they're still in order. And you don't have to write this. I'm just doing this for exposition, explanatory purposes. 7 for baseball, okay? And 4 for kickball. So I'm going to kind of put that in a bracket. These are side thoughts. So basketball, if a circle is 2, so we're going to have 2, 4, 6, 8. Okay, and that could be a little neater, but I think they'll accept that. Volleyball was 3, so we're going to have 2 here. Okay, and we just, whoops, it changed that into an arrow. Let me see if I can backpedal that. Yeah, there we go. I'm not sure why I did that, but so we'd fill that in. And then we can do a half. So it would be that. And we can fill that in or not. By the way, they don't care as much that you're shading it in or not. That's 3. So baseball will be 2, 4, 6, and then a half. So that's 7. And then kickball will be 4. 2, 4. Okay? Now, with these half ones, I'm drawing it like this and filling it in. Okay? We could have also done it this way. They don't really tell us which way to do it. So both of that's okay, and that's okay. Right? We could have done both of those. What they don't want you doing is inventing new schemes. So baseball could not have been 1, 2, 3, which is 6. And then some kids would add on like square equals 1 student and then put a square there. You're not allowed to do this, okay? Certainly that's not what they're asking you to do. They're saying complete the picture graph using this key and only this key. It doesn't mean graphs don't have multiple keys, but in these kind of examples and questions, that's what they're asking you to do, and there's no alternative for that, okay? So there's no way to do it with this. So this deals with parts of a whole, right? Because we're dealing with that. We're still about groups, but it's a different way than the other questions with the number lines. It's also about the visual representation of a graph, okay? And things like that. And we have to realize that it was half, right? So basically what we're doing is dividing each of these numbers by 2 in a way. Because if each circle was 2, so we're going to get 4 circles here. We're going to get 1.5 circles here. We're going to get 3.5 circles here. Right? That divided by 2 would be equal to 2 circles. Okay? And there's no other codes that you're supposed to be able to be using here. It's only circles or partial circles. Okay, and again, just like I drew here, these are 2 valid ways to do it. You could have also done it like this. You could have done a circle like that, where just the top of it was there. You could have done another with just the bottom. As long as it's clear that you're using half of a circle, you could even put it up slanted if you wanted to. Okay, that's not the concern here, right? Because the other part would have been there, right? So as long as you're being demonstrative of that half circle, then you're usually good. And again, it's about representing it, okay? And again, you can't use an alternate. You can't say a box is 1 and then put 8 boxes over here. That's no good. That's a no-go. All right? And I think that's the end of that question. Yes, it was. So just be careful you're following what's going on there. Okay, the next question has no illustration. Let me just make sure it's not falling off the page. No, it doesn't seem to be. So we have a pure word question. So we're going to take it one step at a time, which means one sentence at a time. And within each sentence, we're going to take it a phrase at a time and try to figure out what might be going on here. So Nadia has a strip of green paper that was 18 inches long. So this seems to be one of those questions where I'm going to just start recording stuff. So green is 18 inches. Okay. She cut the green piece into 3 pieces with equal lengths. Stop. So it seems to me that we have 18 divided by 3 equals 6. So each of those is 6 inches. So we have 3 6 inches of pieces of green. Okay? Right? Reread that. Nadia has a strip of green paper that was 18 inches long. She cut the green paper into 3 equal lengths. Right? So these again is dealing with groups and equal lengths. It's a fraction. She's dividing it by 3, so it's in thirds, right? And once we do that, we see that each length is 6. And we can kind of double check that because 6 times 3 is equal to 18, which is the original number that was given to us. She also has a strip of red paper that was 24 inches. So the red is 24 inches. Okay. She cut the red paper into pieces that were the same length as the green. Well, this is a slightly different problem than, so if this is part A that I just did and this is part B, B is a slightly different question than A, right? A said we have a full length and we're going to split into pieces. What's the length of each piece? Okay. In this case, we have the full length, and they're asking how many pieces we're going to get out of it. So what we have to do is take it and divide it by 6 inches, because that was the length of the green pieces. Okay, so if we divide that by 6, we're going to get 4 pieces. Okay, so we have 4 pieces of actually, I changed the colors arbitrarily here, but I did the red and green, and I did the green and red. So I hope that doesn't confuse anybody. That I did not do that on purpose. I just randomly clicked to change colors. So we have 4 pieces. So let me be good. 6 inches per green and 4 pieces of red. Okay? When she was finished cutting, how many pieces of red and green did she have in total? So red plus green, right, equals. So we originally told she had 3 pieces of the green, and we now know that she has 4 pieces of the red. I said that backwards. She has 3 pieces of the red and 4 pieces of the green. So that would be equal to 7. Okay? All right, and that's all they're asking you to do here. What happens is, let me change the color of the pen one more time. So this is still about equal parts, units of 1 and so on. What some kids are going to do is they're going to start mix matching, because this is inches and this is pieces. They may do 6 plus 4. equals 10. Okay, and that's no good. They're mixing units, mismatching units. Okay, so you can't do that. And what some kids do is they add the 18 into 24. Okay, and they start getting, what is that? 20, 30, that's 40. They start getting stuff. That's not it either. Just make sure you're keeping track. If you break it down per sentence as I've done, you should be able to get where you need to do. And so, by the way, this now goes beyond groups. It's also still dealing with the multiplication table, which is vital to a lot of stuff, guys. So you guys should be really fluid in those kind of things like that. It's also dealing with operations. So did the previous example. We're going to deal with division, multiplication, subtraction, addition, stuff like that. So you guys need to know your operations or whatever as well. This is also dealing with what's, you normally don't get involved into this deeper until like grade 7, 8 when you get into more algebra. But it's also dealing with how to deal with like groups and unlike groups. Inches are not pieces. Total is not subparts. So those are things we need to learn. And that's why we have to do the 3 with the 4. There's no other connection there. The 18 plus the 24, that's inches. So that's 40 inches altogether. But it said how many pieces, right? So we have to keep our units the same, which is our terms. We can't add pieces to inches, right? That addition makes no sense, or subtraction for that matter. Okay, so that's kind of a no-go, and that's where kids can get astray on this. So we have a word question. You take it a sentence at a time. You build it up. You write down your givens as they're given to you. You solve problems as you can, and once you're done with it, you try to make sense out of it, right? You try to make sense out of it, right? If you ended up with an answer like 2,000, how did you get that from here? Similarly, if your answer was like one piece, that seems wrong too, right? So you have ways to do double checks, even if they're not 100% double checks. You still have a way to do it. It's often said if you take your answer and feed it back into the question, you can get the answer. Well, this is a word question. It has subparts. We had this subpart right here. That's number 1. Then we had to take that answer here, which is 2. So it is subpart 2. And then finally we had to do the subpart 3. So this is at least the 3-step word problem that we had to worry about. So there's that too. It's about word problems. Whereas the previous question was a visual one, this was a word-oriented problem as well. So that's some of the concepts and stuff that we're throwing back and forth with a lot of this. All right? Okay, 49. And again, we can use what they ask us here for the hint, that we're looking for pieces. We're not looking for inches. So we have to do the mapping properly. Okay, let me make sure this lines up again. Okay, that looks good. So we have an illustration again. We have a key where it's telling us the shaded in square, it looks like, is 1 square yard. So that means when we have this, that we have, if this was A and this was B, so A times B equals square feet. Well, in this case, that means this must be 1 and this was 1. Okay? And it's in yards. So our units so far are in yards. This is 1 yard by 1 yard, which gives 1 square yard. So at least we're understanding that, okay? We have, now the illustration, we have an unshaded area and then a shaded area. So we can count again like we did last time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. And right, we have to balance this off that we're only still looking at the illustration. So if you were solving this on a real test, I would have postponed writing all these numbers out till we even know what we're being asked. Because we may not be asked anything about the shaded area. We might be asked about the unshaded area. Okay? And anyway, if now looking at the unshaded area, we see this is 9 yards and this is 7. So the area of the area inside of here is going to be equal to 63 yards squared. Okay, we can do yard like 2, or it can be SQ yard, or we can write it out like it has here. 63 square yards. Okay, they're all valid ways to write square yards, right? And this is YD with a little 2, a superscripted 2 is one way to do it. Okay, and again, even this multiplication, this 9 times 3, we don't know what we're going to be asked here, so it's unclear. Okay, and just to explore it further, this is 1, 2, 3, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So we see this shaded area, the area of the shaded part is equal to 3 times 9, and that's equal to 27. So we can almost see as we're looking at this, well, if this was 9 times 7, right, and this is 9 times 3, is it going to go back into that distributive property kind of question it was asking us before in the other question? I don't know. Let's see. All right. And again, I'm exploring this before I look at the words. I would have looked at the words already on a real test. I'm just trying to kind of heads up and kind of giving you kind of an inclination of where to start leaning on some of these. And even now that I said that, just looking at the original illustration without my annotations, you have an unshaded area and a shaded area. You should see the distributive property leaping out on that just by itself. Okay? And that doesn't mean this is a distributive property question, but most likely it is. Okay? All right, so Mr. Nuccio has a sandwich shop that is 9 yards long and 7 yards wide. Wait, my pen tablet is going. Okay, so we have 9 yards long and 7 yards wide. So we can see that. This is the length, and this is the width according to what they're telling us. Okay? And before he added a new section, the shaded area, so this is the original, if you will, and the whole shaded area is the new. Okay? So he originally had a sandwich shop, and then he extended it. Okay? The shaded area below shows the new section. So if we go to the question, what is the total area in square yards of a sandwich shop after the new section was added? Okay? And then show your work. So there's a couple ways we can do this. We can do the 9 times 7 is equal to the 63. And then we have the 9 times 3 is equal to the 27. And we can just add them then, because that's the area of the new plus the area of the old. We get 7, 0, 1, 6, 7, 8, 9. So we should get 90 square feet. Okay? If we're doing that. Right? And we have an analogous situation that what we're doing is the 9 times 7 plus the 9 times 3 equals the 90. Okay? This is also the same as 9 times 7 plus 3 then. Because that's equal to 9 times 10. Okay, so that would be the 90. So there's a couple of ways we could do this. We can take it by the pieces, or we could have looked at the whole thing. Because let me change the color of this one more time. If this was 7 here, and we're going to add 1, 2, 3 to it, that means the length of this whole thing here is 10. So now we have 9 times 10 equals 90. Okay, so there's a couple ways we could have got this answer by using distributive property, by using brute force, just by combining the two of them, if you will. And the combination is through that. And again, our hint here is square yards. Okay, we're not just looking for one of the sides. We're not looking for 9 or 10, right? Some kids do the 7 plus 3 here that I just did at the bottom to get this 10, and they say the answer is 10. That's no good. You can't do that, okay? And again, this deals with multiplication table. So if you don't know what 9 times 7 is, your answer is going to be wrong. So this is also, it's also about visual, the visual representation again of the distributive property. Okay, now remember, a lot of kids are also going to get bogged down with the illustration and do something like the 9 times 3 equals 27, and then they're going to say 27 is the answer. You haven't finished the problem. Okay, it'll be less likely that some kids are going to do the 9 times 7 and get 63 and write that as the answer. It's that you're getting so absorbed into the problem. So it's worth going back to reread the question, looking at it cool and calm and collected, and then just trying to combine the different pieces. Because it doesn't say what is the area, right? It says he started a sandwich shop, and then he added a new section. And then the question is, what is the total area of the new and the old? And it even tells us that after the new section was added. So they're not asking for the area of the new section. They're asking for the area of the old section plus the new section. All right. So remember to finish your thing. Finish your questions. Don't just stop midway. All right. So we have an illustration. We have 4 green, 3 red. 1, 2, 3, 4, 5, 6. I'm going to count the backwards. 1, 2, 3, 4. We have 6 blue. Okay. I have no idea what this is. Oh, it says this is a keychain. I guess that's the ring for the keys here. This is the ring here. And let me put ring instead of R so I'm not implying it's red. And then each bead must be on a string of some sort. So just in case it's needed, we have 7, we have 13 beads altogether. Okay. That may or may not come into play. So Sharon wants to make keychains with different colored beads as shown below. Cool. So let me scroll this slightly. Let me make sure that still stays on the screen though. Give me 1 second. All right, that's good. So we probably have enough space to show our work. Then it says, so this is the requirement for each keychain. There's 13 beads distributed in the ratio 4 to 3 to 6, as in green to red to blue. All right? Each keychain will look the same. Awesome. So it seems to me if she does 2 keychains, she's going to use 26 beads. In particular, she's going to use 8 green, because it's 4 times 2, 6 red, 3 times 2, and 12 blue, 6 times 2. All right, 26 beads in that distribution. So it says she will use a total of 20 green beans. And excuse me, I keep saying beans, but it's saying beads. So if I keep mistakenly saying that, we're cool. I have slight dyslexia, and sometimes, especially numbers appear differently, but sometimes words do too. So welcome to the world of dyslexia. What you do is you just keep making sure what you're seeing is what it is and redoing it. In any event, Sharon will use a total of 20 green beads to make all of her keychains. Okay, so she's using 20 green. Okay, it seems to me that if it's 4 per thing, then she's probably dividing that by 4. And that probably means she's getting 5 keychains in total. Okay, let's see what they're asking us. What is the number of red beads and the number of blue beads she will need to make all of the keychains? Okay, so yeah, we can use this. So we use the total number of green beads she had, right? We have total divided by the per. There's 4 per. So we notice she has 5 keychains. Now that we notice there's 5, and we need 5 keychains, if the red is 3 per, right? There's 3 red per each keychain, and there's 5 keychains. That means she needs 15 red. And the same for the blue. If each keychain uses 6 and there's 5 keychains, then she's looking at 30 red. Okay? And then what we have to do is it's asking us what is the total number of red and the number of blue she will need to make. So we can add that up and get 45. Okay, and if we look at what they're asking us here, right, they're asking us to split that up. So it would be 15 and 30 here. Okay? They're not actually looking for the 45. All right? There is another way to solve this. Let me change the color of the pen. If we know there's 13 beads per keychain, right? Once we know there's 5 keychains needed, that if we multiply that whole thing by 5, we're going to get 65, right? And we can backtrack off it from that way using the same ratio that we had up here, right? We already know this 20. It tells us this 20 green, so we're left with 45 of red and blue, right? And if we use their ratio, we can get that out of that as well. All right, so that's another way to do it, kind of as a double check, if you will. All right, so again, this also involved groups. The whole was 13 beads, and this is unequal parts now. Some of the other examples have it. And if we write this as fractions, out of each group, there's 4 out of 13 green, 3 out of 13 red, and 6 out of 13 blue. So they're unequal parts, but it's still in a group. There's still a group in each keychain. We also dealt with subtraction. We also dealt with other operations, because again, you have to know the multiplication table to be able to do 6 times 5 and 20 divided by 4 and stuff like that. Okay? And it's just important to try to get those things out there, that's what you're doing. Remember not to flip the answers. Don't get green confused with blue, confused with red. That's a gotcha with some of these kind of things like this. Label things. It's important to put this label here, and this label here, and this label here. This way you're keeping track of it. And like the previous example, write your givens down as you're coming across them so that you have a way to keep track of it. If you're solving these problems in your head, it's so easy to start getting them wrong and things like that. There's another aspect of this here too, which is that we have the notion of repeated addition, which is what multiplication is, and repeated subtraction. Okay, so if you don't know, we can, originally you told us there were 20 green beads. We can do 4, 8, 12, 16, 20. Oh, so that would be 1, 2, 3, 4, 5. So there's ways to incorporate concepts like that into this as well. There's also would be not only repeated addition, but cumulative addition, right? Because we're adding, okay? And of course, the gotcha, even when using the multiplication table, is to not make a mistake. It's so easy to make a mistake. That was part of the thing with, if we come back to this, when I wrote down the 1 through 27, it's so easy to make a mistake there, and I could have ended up with 28 or something like that, or 26 even, if I ended up, depending on whether you add one twice or skip one, or just lose track. So attention to detail is another issue through all of these kind of questions. Okay, 51 is changing gears somewhat. It's moving away from the number line and the other things, but it's also dealing with the visual representation of something. Okay, so we have, let me shift this slightly to get that on your screen better. Okay, there we go. So we have three, it looks like squares that are divided up into different ways. So it says, shade the models below to show three equivalent fractions and explain why they are equivalent. So this is kind of a loaded question. The real observation to note is that this first big A has two parts. Let's call it X and Y. Okay, so it's in two parts. So this is the most obvious answer to the question, which is that if I shade this now here to be half, right? And this is in 1, 2, 3, 4, 5, 6 things, that if I shade 3 of them, that's half there. And then if I do half here, right? I can do something like that. So that's the most straightforward answer. There's a lot of other answers to this that deal with this, but this is basically 1 out of 2. This is 3 out of 6. And this is 2 out of 4. So we know 3 out of 6 is also a half, and we know 2 out of 4 is a half. So what we're trying to take is the fractional representations visually, okay, and being able to do stuff like that. It turns out that if we were to do, like, redo C over, C could have been done that way, okay? C could have also been done this way. Or conversely, that way. And C also could have been done this way. We shade this one corner here and this one corner here, right? That's still 2 out of 4. That's still a half. Okay, so there's a multitude of ways to do a lot of these things. When push comes to shove, we could have also, if we wanted to, drew an extra line, line through A, like that. And we could have shaded it this way. We could have shaded this top and this bottom part. We could have shaded this left and this right part. Okay, it's just saying show 3 equivalent fractions. That still would have been a half. Or in this case, since I would have made 4 parts, it would have been 2 out of 4. We can come here and we could have, with B, we could have done this and then done this and then done this. Is that not still 3 out of 6 of them? Okay. And with B, we could get even more involved and do something like, let me make that purple. If I split along here, I could have done this, 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 right? That, and that. That's still 3 out of 6 and it's still a half. So there's a multitude of ways we could have gyrated this. The initial way was the most straightforward way, and the explanation is to show that the fractions are all a half. Okay, so the initial observation really, for me personally, is based on that A was in 2 parts. Okay, but it even says to show 3 equivalent fractions. Shade the models below. So in a way, you could have done whatever you wanted to, as long as you were correct. Okay, you could have gone beyond a half. You could have used like fifths or something like that, really technically, just to prove a point. But that's really pushing the issue, and that's not really the concept they were just testing. They were just testing simple fractions and their simplification and the visual representation. And again, this deals back with equal groups, equivalent fractions, right? And the concept in this case, it was really of a half. Okay? And we're finally up to, I think this is our last question. And it's a word question. Let me just make sure this is showing on your screens. One more second. And this is good. We're just about at the minute point here. So we're going to probably go an hour and 5 minutes or so along with this. All right. So there were 80 adults and 20 children at a school play. Cool. There were 100 people. Let me just see if that matters. 120 plus equals 100. Okay, I don't know yet. I'm just writing stuff down. And by the way, I could have wrote this 80 plus 100. 80 plus 20 is 100, which is adults plus children. Okay. The school collected $8 for each adult. Okay, cool. And $3 for each child. Okay, so if we were to map that, it seems to me that if there were 80 adults and each adult paid $8, then we're $640 for the adults. And $3 for each child. So if there were children, there were 20 children at $3 each, then that's $60. And I don't know where they're going here, but in total, it would be $700. That would be for the adults plus the children. Okay? So let's reread it to make sure everything I'm writing so far makes sense. There were 80 adults and 20 children at a school play. The school collected 8 for each adult and 3 for each child. The school donated $125 of the money to a local theater. Okay? So it seems to me that they're now going to take the 700 and remove 125 from that, which is the donation. Okay, we can either do this on their head backwards, or we can do borrowing. So we get 69 here, 1, 5, 7, 5. And we can double check that, and you should always do that. So 575 plus 125. 5 plus 5 is 10. 0, Carme 1. 7, 8, 9, 10. 0, Carme 1. 5, 6, 7. It checks out. Okay? So this is what is left after the donation. Okay? So the school donated $125 of the money to the local theater and used the remaining money to buy supplies. So this is for supplies. Okay. Now the question finally comes, how much money does the school have to buy supplies? That's the answer. We got it. We computed it. Okay. So we took it a piece at a time, a sentence at a time. We broke it down. We gave what the givens were. Okay. This is still also about parts, but if you notice, there's a discrepancy because we didn't break down the numbers 80 out of 100 versus 20 out of 100. Okay. We couldn't do that because the price per ticket for adult versus children tickets were different prices. So we couldn't do that. So other groups, we're dealing with rates now. Right? The rate for adult was $8 per ticket. The rate for a child was $3. Okay? We're also dealing with adding unlike things. Right? We had the adults is not the same as children. They were different prices. So we had to conceptually break that down into its own subpieces and merge it back. Because at some point, even though there's adults versus children, at the end of the day, the money is the same. The money still adds up. Dollars are dollars. So again, this deals with groups, uneven things. It deals with fractions. Even though we didn't deal with the fraction head on, we still had to conceptually understand that there were groups that were split into certain parts. Okay. It also dealt with knowing your operations. This was a multi-step word problem, right? Where first of all, we had to realize what do we have. Then we had to break it down and get that. And then we had to do this part over here. So this was at least the 3-step word problem that we had to visualize. Again, write down your givens, right? And you have to know your operations. Like this subtraction involved borrowing. A lot of kids messed this up. Okay? And again, just like the example before was a multi-step word problem, don't just get to 700 and think you're over. You haven't answered the question yet. That's only an interim value, a partial, temporary value that you have to use for the next step. Okay, you need to know your addition, subtraction, multiplication table again, and there's just all these different ways that are going on that you need to worry about, be concerned about, right? All right. So let me just double check that the last question. Yes, it was. All right. So hopefully you guys are getting something out of this. Please like and subscribe. There's more to come, a lot more to come. And I do other videos. I have hundreds of videos already on the channel. Please go and check them out. Please check out GregsTutoringNYC.com. Smash that like button. You guys need to email me, whether you need tutoring or have questions or whatever the thing is. I'm very open. I'm very happy to help you guys. GregsTutoringNYC@gmail.com. Hit me up.